All right, so now that we have talked about energy and types of energy, we are going to talk about energy conversions. So the definition of an energy conversion is to change from one form of energy into another. So remember we said that energy just doesn't just disappear or form, it's made into another form as it's converted. So one form can sometimes be transferred and converted into just one other form. Sometimes one form turns into many different forms. It just depends on the situation. We've talked about kinetic and potential energy and how there's switching back and forth depending as things start to move and then as they start to slow down. But there are many times that we go back and forth between that kinetic and potential energy because we're constantly stopping and starting. So one example that I like to use is jumping on a trampoline. So as someone jumps up, and I will say the last slideshow, it wouldn't show me where I was writing, and I'm not sure, so I'm going to try my best to draw without seeing what I'm drawing, so don't make fun of my drawings. We have a person. I have no clue what I am seeing. It's not showing me the lines here, or what I'm drawing. Not showing me the lines, so I'm just drawing blind. But if we have a person, and we have a trampoline, I hope that's somewhat of a good picture. As that person goes up, they have kinetic energy. But when they stop at the top briefly, when they're barely, for a split second, they're hanging there in the midair, they have potential energy. And then as they fall back down, they have kinetic energy again. And then so forth, so far, and so forth and what have you and whatever. If I could talk, that would be great. And also then at the bottom, they will briefly stop and have potential energy again. So they continuously are switching back and forth and back and forth. Same with the pendulum. You have a pendulum, which if you don't know what that is, it's like a grandfather clock kind of thing. You have, if we have a ticking clock, it's going to swing this way with kinetic energy. Somewhere over here it'll stop very briefly and have all potential energy, and then swing back that way with kinetic energy. Again, I have no idea what I'm drawing because for some reason the pen's not showing up on here, but it shows up afterwards in the video. So hopefully that makes sense. But we are constantly stopping and starting, so we're constantly switching back between kinetic and potential energy. There's also a ton of different conversions with chemical energy. So our body converts chemical energy from food into both kinetic energy, which is us moving, and into thermal energy, which is keeping our body temperature. So the food we eat gives us chemical energy, and then we make that it gives us the ability to move and to keep our body temperature regulated. Photosynthesis with plants takes light energy and it turns it into chemical energy. It turns it into sugar. So chemical energy is very important when it comes to living things and how they're able to survive. Electrical is also a huge one. Ever since the invention of electricity, we have obviously we very highly rely on electricity to do things. So it's very easily converted into other forms, which is part of the reason it's so convenient and so popular. Just a few examples here. Alarm clocks they take electrical and they make it into light and into sound. Batteries take chemical energy from the acid and whatnot and they make it into electrical. Light bulbs take electrical and they make it into light and they make it into thermal with the heat that comes off and the light it gives off. And then a blender would take electrical and it makes it into kinetic as it moves, and it also makes it into sound. So we're going to do a practice worksheet here when the day these notes are due for you guys to practice writing these conversions. So you have to be able to identify, what does this machine or whatever take, and how does it take that one form of energy and transfer it into another kind or two. So we've talked, all last chapter was on machines. We know that machines make work easier. They don't take any work away, but they make it easier for us because they're able to transfer that energy elsewhere. Energy converters are things like car engines. They take chemical energy from fuel and they transfer it into thermal energy, into kinetic energy to help our car move. Obviously, that makes it work a lot easier to travel. Doorbells, they take that electrical energy and they make it into sound energy, and they make it easy. They make less or easier work for us. Windmills take kinetic energy from the wind and they make it into electrical energy. Telephones take electricity and convert it into sound energy. So they're all these things that have made our lives easier, made us have less work, easier work, because they were able to transfer that energy. And lastly, it's just kind of how important energy conversions are. So energy conversions make the energy useful to us, essentially. There's so many different types of energy that we've talked about that if we didn't have a way to convert it, then it would really be useless. Nuclear energy, for the most part, for us, would not be very useful if we didn't have a way to convert it into electrical energy. Same with things like electrical. If we couldn't convert it, it really wouldn't have service any purpose. It wouldn't give us anything besides shocking us, or lightning and things like that. So the more energy output we have compared to the input, we know, we talked about with machines, that means the more efficient the conversion is. So that means we have less waste created. So that means that we've had less energy that be given off to friction, and so we're getting the most energy we can out of it.